Okay, so this is the question that I gave. Let us continue from here. So this is a question under absolute error. So it is saying that Amanda, this is how the question is. Amanda measured the length to be 9 centimeters and Nancy's measurement was 9.8 centimeters. Given that the true measurement was 9.5 centimeters, calculate Amanda's absolute error. This is the question which you are given. So, I'm from telling you that we know that when you are having an O number, let's say you've got an O number like 10, 11, it can be 2, as long as it is an O number. The absolute error of that one, it is what? It is 0.5. This is the absolute error. If it is a 1 decimal place, let's say 2.2, 12.5, as long as it is having a 1 decimal place or a 1 decimal point, the absolute error is 0.05. This is what I was talking about. Hope we are able to understand, we are able to get one or two things. So this is how we get to calculate the absolute error. But this question is different. This is a different question. So in this question, what are we given? We are given these two individuals' measurements, and we are also given the true measurement. How can you go about such a question? So this is what you are going to do for you to answer this question. You are going to get the true measurement. What we avoid whenever we are talking about measurements, you need to avoid a negative number because these are measurements. You cannot say negative 2 centimeters. No. We follow what? Positives. So, what is the true measurement? The true measurement was 9.5 minus Amanda's measurement. Amanda's measurement was what? 9 centimeters. So, minus 9 centimeters. What are you going to get? When you subtract here, you are going to get 0.5. Meaning this is the what? The absolute error. This person missed the true measurement by 0.5. So this is the what? This is the absolute error of Amanda. So this is the what? Absolute error. Like that. So this is how you need to calculate that one. But if you are just given a question, let's say a person measured a measurement to be 10 centimeters, then you are asked, what is the absolute error? You go to this one here, which I've said that when it is an O number, then the absolute error is 0.5. If it is having 1 decimal place, then the absolute error is 0.05. This is what you need to know. Don't put 3 here, don't put to know. Don't put those things. So this is what you need to know, understand, and get. These are principles that you need to know. These are things that you need to understand. You need to make sure that you understand all these things properly. So we've calculated that person's absolute error. So we move to this other question. It is saying, calculate Nancy's percentage error. You want to calculate Nancy's percentage error. How can you calculate the error that Nancy made in percentage? So I'm going to say percentage, I'm going to abbreviate. Percentage error is equal to, percentage error is equal to relative. So relative error, like this, relative error times what? 100%. This is the formula. This is the formula that we are going to use. So in other words, we need to calculate Nancy's relative error. This is what we need to do. We calculate Nancy's relative error. This is what you're going to do. Nancy's relative error. You calculate that one. So how do you calculate relative error? So percentage error is also equal to relative error. You know that it is absolute. This is what you know. Absolute error over true measurement. Over true measurement. This is measurement. Then you say multiply by, this is measurement. You can complete it, times 100%, like this. This is what you're going to do. So this is the formula that you need to get. This is the formula that you need to understand. So where you are going to continue and say, this is equal to, what is Nancy's absolute error? So Nancy's absolute error, you check, what is the error? What was the measurement for Nancy? The measurement for Nancy was 9.8. But the true measurement was what? 9.5. So you start with the bigger number. 9.8 minus 9.5. What are you going to get? 0.3. So this is the what? Absolute error. For who? For Nancy. So this is the absolute error for Nancy. This is what you need to do. So with this 0.3. So you cannot start with 9.5 like the way I did with this one. You always start with a bigger one to avoid negative answers. So we make sure that we avoid negative answers. We need to avoid negative answers. So with this now, you continue where you are going to say that the absolute error of Nancy was 0.3 over true measurement 9.5. Then you say multiply by what? 100. You multiply by 100. Say 100%. So once you calculate this one, then you are done. This is how you need to calculate these ones. That's how you need to work out all these. So how do we get to multiply these? How can we multiply these? How can we multiply this? You know that 0.3 times 100, you are going to get 30. So you are going to get 30 there. Then you say over what? Over 9.5. The percentage, you forget a bit about the percentage so that you do the calculations very well. Then you are going to come to the percentage. This is what you need to do. Then we are going to come back to the percentage. Then you say, here, how can you change this? How can you divide here? You say, okay, you change this one first. You say times 10 here to cancel the point. Times 10. So which answer are we going to get? That one will be 300 over. This one becomes 95. Then you can further what? Don't forget the percentage is coming. I haven't forgotten about the percentage. I just want us to deal with the numbers so that I just include the percentage later on. So which number can go into 395? It is 5. So when you say 300 divide 5, it is what? There, divide 5, you get 60 over. 60 over. 60 over what? You say 95. 5 into 95. What are you going to get? 5 into 95. What you are going to get is what? Is 19, like this. So if you cannot further reduce this one, you can just now put the percentage because you cannot reduce it. Have you seen? So this was just an example. This was just an example. This was just an example. This was just an example that we need to get. This was just an example that we need to get. So this was just an example that we needed to get. This was just an example that we need to get. So with this now, what is your answer now? So you just end there. This is your what? This is your answer. This is how you need to work out this one. So that is all the calculations that you need to do. Like this, you are done. The other part that I also want you to know is the relative. You also need to know tolerance. So how can you calculate the how can you calculate the tolerance? Can you calculate the tolerance? So how we get to calculate the tolerance is very simple. I'm going to show you. So if you are taught to calculate the tolerance, how can you calculate that one? So what you need to do is this one. Have you seen what you need to do is this one? You need to, let's say you are having a number like, you measure a number to be 9. Let's say it is what? It is 9. 9 centimeters. This is the value measured. Then you are told to calculate the tolerance of that number. So how can you calculate the tolerance of that number? So what you are going to do for you to calculate the tolerance of that number, you just say, we say upper limit. So upper limit minus, this is upper limit minus lower limit. Lower limit. This is the formula that you get to use. Then you calculate the what? The tolerance. This is what you need to do. This is the formula. This is minus here. So what you need to do is that you know that, okay, what is the upper limit? First, what you need to do is that you calculate the absolute error of that number. Have you seen? You calculate the absolute error of this number. So what is the absolute error? I told you that's 0.5. So to find the upper limit, you say 9 plus 0.5, like that. You say minus the lower limit, you say 9 minus 0.5. This is what you're going to do. So we are calculating what? The tolerance, like this. So where I'm going to say now that tolerance is equal to what? Tolerance is equal to, what is 9 plus 0.5? It is 9.5 minus, here I'm going to get what? I'm going to get 8.5. This is what I'm going to get, 8.5. So that is the 8.5. Then I say now, therefore, tolerance is equal to, so tolerance is equal to what? Tolerance will be equal to, that is, so what are you going to get? Is it 0.1? 0.1, right? 0.1. Confirm with me. Can you subtract there? What are you going to get if you subtract there? What are you going to get? What are you going to get there when you subtract? What are you going to get? What are you going to get when you subtract? When you subtract, what are you going to get when you subtract? What are you going to get when you subtract? This one. So the answer is just 1. Let me use another. The answer is just 1. Hope you are able to follow. The answer is just 1, like this. So this is your what? This is your tolerance. You've calculated the tolerance. So this is how you need to calculate tolerance. Let me give you another one. Let's say you are given a question. Let's say you are given something like this. You will be given some equation like that in so many ways. So let's say you are given like this. They will tell you that maybe a mass, they will say a mass of So they'll put something in brackets here where they are going to say that 20.5, they are going to say 20.5 plus or minus. So plus or minus, then they'll say 0.05, then they say kg here. Have you seen the way this question is? Then the first question, maybe you are taught to calculate tolerance. They are telling you calculate what? Tolerance. How can you calculate tolerance? How can you calculate the tolerance? So what you are going to calculate is this. This play here, the correct spelling is E here. So just need to correct that, which I did at first. This is the correct spelling for tolerance. This is what you need to do. So now you know that when you're given these two, this one which is here, this one is the what? Absolute error. You know that that's the absolute error. So how are you going to calculate tolerance? You're going to say that tolerance is equal to upper limit you add. So it's 20.5 plus what? 0.05. Then you say minus the lower limit. What is the lower limit? The lower limit is 20.5 minus 0.05, like that. So tolerance is equal to, like this. This is the tolerance is equal to. So when you add there, what are you going to have when you add? Which answer are you going to find when you add there? So you are going to get what? You are going to get 20.55 minus there. What are you going to get? 20.5 minus 0.05. What are you going to get? You are going to get 20.45, like this. This is what you are going to get. So where you are going to say now t is equal to, when you subtract there, what are you going to get? What are you going to get? You are going to get 0.1. So this 0.1 is called your tolerance. So this is what you need to know and understand. So let's make sure we get this. Let's make sure that we understand this. So just on this one, this is the correct spelling. Let's get this one. This is the correct spelling for tolerance. So this is how questions will be coming. Thank you so much.